Alright, so we've been talking about the law of conservation of matter, and we're going to do some examples today. So first I'm going to weigh this jar of water. So it weighs 528 grams. So let me just record that. And then now I'm going to weigh this sugar. And it weighs 143 grams. And so now I'm going to mix the sugar with the water and let it dissolve. Uh-oh, that might mess it up. All the sugar needed to go in there. So let me see if I can get this sugar in. Alright, so we can see the sugar is kind of starting to dissolve. We can't totally see it, but we can still see some of the sugar. But what would you expect it to weigh? So let's put it on the scale and see. So it weighs 546 grams, or 545 grams. So if we add these two together, oh, we also need to put the glass bowl back on there, because we had all of that. So when I add these together, I get 671, so it is really close. We would have expected it to be the same, but since I did spill a little bit of the sugar, that might be why it's off just a little bit. Oh, and actually it did show 671. So I want you to now tell me why this example shows the law of conservation of matter. Okay, so if I wanted to see just how much the sugar weighed, I could weigh the glass bowl. And so it's 125 grams. And since I know the sugar and the bowl were 143, then I can just subtract 143 minus 125. And so this will give me how much just the sugar weighs, not in the bowl. So that gives me 18 grams just for the sugar. So I could have done that, but I ended up just keeping it all put together. So we're going to do one more example. I want you to tell me how this also shows the law of conservation of matter. So I've got a bottle of water that I'm going to weigh. And it weighs 542 grams. And then I have a package of strawberry lemonade. It weighs 4 grams. So whenever I mix them together, what do we expect it to weigh? So I'm mixing this together. And I'll shake it up. And so we would expect it to weigh 546 grams. So let's see if that's what it weighs. I'll put this packaging back on since we had it. And so it's really close, it's 545. So how does this example show the law of conservation of matter? So just because the scale may not be as precise You know, we know that the matter was not created or destroyed. So think about that while you are writing your explanation of why this shows the law of conservation of matter. Okay, so we've already done a lab with the baking soda and vinegar blowing up the balloon. And remember, that showed a chemical reaction in which the solid baking soda mixed with the liquid vinegar and produced a gas, carbon dioxide. So I'm going to show you this one more time, but this time we're going to look at how much the baking soda and vinegar weigh before we do the chemical reaction. So it weighs about 125. Earlier it went up to 126, but we'll say between 125 and 126. And so now I'm going to blow up the balloon like we did before. And I want you to think about how this example is going to show the law of conservation of matter. So we already determined there was a chemical reaction because a new substance, the gas, was produced. I don't think I got it on as well as I needed to. So some of the gas might be escaping. And I don't want to mess up the scale, so I'm going to wait just a second before I put it back on there to see what it weighs. Alright, so we're going to try this one more time. Alright, I want you to explain how this chemical reaction is an example of the law of conservation of matter. So why this shows the law of conservation of matter. We've got the balloon and with the baking soda and then the vinegar at 134 grams. So now I'm going to blow up the balloon. And we're doing a chemical reaction here. And so now we want to see that it is blowing it up, and we can see that it's 134. It's going between 133 and 135, but it's really close to our same weight. So it's the same. At one point it did say 134, but now it's saying 133. So we made a gas with the solid baking soda and the liquid vinegar, and we did a chemical reaction. We weighed it before the reaction and after. So I want you to tell me why this shows the law of conservation of matter.